This video is presented to you by www.testprepadda.com. Dear students, in the previous session of General Organic Chemistry, I started the discussion of hyperconjugation. In that session, I told you that hyperconjugation is associated with alkyl cation, that is RCH2 plus, alkyl radical, that is RCH2 without electron, and double bond or better I say unsaturation having alpha CH. So basic condition for hyperconjugation is the presence of alpha CH bond. Let me show you. If I say this as the radical carbon, then the carbon which is directly attached with this is known as alpha carbon, and hydrogen atom attached with this carbon is known as alpha hydrogen. So the presence of this alpha CH is must if it shows the hyperconjugation. My point is clear. Now for alkyl radical, I will talk about the hyperconjugation in this session. If I take the example where this CH2 is attached with CH3, this carbon is having odd electron. This is alkyl radical. Okay, now how many alpha hydrogen atoms are attached here? 3. And with respect to this carbon which has this odd electron, with respect to this carbon, the structure is nearly triangular planar. It is nearly triangular planar. So if I draw the orbital diagram with respect to this, it is triangular planar. So I'll write this carbon here, one orbital bond with hydrogen, one orbital bond with hydrogen, another orbital bond with carbon, and 3 hydrogen atoms are attached here. And one orbital, that is p orbital, is perpendicular to this triangle which has this odd electron. My point is clear. So this p orbital is singly occupied. Now rotation about this carbon-carbon bond is a free rotation because this is a single bond, carbon-carbon single bond. Now if the orientation of any of these CH bonds, if the orientation of alpha CH bond is proper and in the sink of this singly occupied p orbital, then sigma electrons of this CH bond delocalize with this p orbital, singly occupied p orbital of neutral trivalent sp2 hybridized carbon. This delocalization is known as hyperconjugation. My point is clear. This is known as hyperconjugation. Now this hyperconjugation involves electrons of this sigma bond, sigma orbital, and this p orbital, singly occupied p orbital. That is why this delocalization is also known as sigma p delocalization. Sigma p delocalization. My point is clear. Now I will show you how to write hyperconjugative structures for this alkyl radical. The principal structure is this. Now this hydrogen, if participates in hyperconjugation, this bond will be broken and this bond will be broken in such a manner that each atom gets one electron because one electron is already here. So the hyperconjugative structure here will be written as this. Now if this hydrogen participates, then the structure will be written as this. If this hydrogen participates, then the structure will be written as this. So there are three alpha hydrogen atoms. That is why we are able to write here three hyperconjugative structures where hydrogen is participating in the alpha hydrogen is participating in the hyperconjugation. My point is clear. Now you can see more number of alpha hydrogen atoms, more is the delocalization of this odd electron. In this principal structure, the odd electron is on carbon. Now you can see here on hydrogen. Here you can see on hydrogen. Here you can see on hydrogen. The extent of hyperconjugation will be more if number of alpha hydrogen atoms is more. Another point, you can see this carbon and this hydrogen does not have any bond. He also does not have any bond, and that is why this delocalization is also known as no bond resonance. No bond resonance. My point is clear. Now let me summarize whatever I discussed here. Now summary is, hyperconjugation in alkyl free radical is of what type? Sigma p conjugation, and is defined as delocalization of sigma electrons of alpha CH bond with adjacent singly occupied p orbital of neutral trivalent sp2 hybridized carbon. Basically, we are talking about this carbon. More number of alpha CH bonds implies more delocalization. It's true. Hyperconjugation is also known as no bond resonance because there is no bond between alpha carbon and alpha hydrogen in the hyperconjugative structures. Second, as in alkyl cation, here also hyperconjugation is known as isovalent hyperconjugation. Dear students, recall what is isovalent hyperconjugation. I have written here hyperconjugation in which the hyperconjugative resonating structures have same number of bonds as in the principal structure is known as isovalent hyperconjugation. Let me show this to you. Just count the number of covalent bonds in this principal structure. 2 here, 1, 2, 1, 3, 4, 5, 6. 6 covalent bonds are here in the principal structure. Count here. 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4 and 2 from hydrogen. So total 6. So the number of covalent bonds in this hyperconjugative structure is same as the principal structure. That is why is also known as isovalent hyperconjugation. Dear students, in the next video lecture, I will talk about case 3 of hyperconjugation, and that is the unsaturation. For example, double bond benzene. Thank you. This video is presented to you by www.testprepadda.com. TestPrepAdda.com provides free audio-visual lectures of different subjects by expert faculties, free online tests prepared by expert faculties to students who are preparing for engineering or medical entrance exams or planning to take exams like KVPY, Olympiad, etc. It provides a platform where students can interact with mentors to improve their performance in the exams. The mission of this online medium is to help students to achieve their goals. Log on to www.testprepadda.com to watch free video lectures on different topics, to download free revision notes, to take free chapter-wise online tests, progressive test, and mock test, to discuss doubts with mentors. Thank you for watching the video. To stay up to date with the latest videos, subscribe to our YouTube channel. Like us on our Facebook page, Test Prep Adda. All the best.